No, I'm just going to start it without you today. Take a quick look, write really fast. We're going to move on. Pause, write it down, catch up to this. Okay, cosine of 75 degrees. If you look on your green sheet, you won't find 75 degrees on there.
No, you don't.
No, you don't. But can I rewrite 75 as, let's say, the sum of two numbers that add up to 75 that are on that sheet?
Like 30 and 45.
Oh, so I think it's perfectly legal to say that 75 is equal to 45 plus 30.
Oh, I see what you're saying.
You see where this is going? So now I can use my identity, because my identity has these four values, and these four values will be on the green sheet, where 45 is my A, 30 is my B. So now I'm going to use the identity to expand this and then get the four values from the sheet. So if I expand, the identity says take the cosine of both of them, so it's the cosine of 45 multiplied by the cosine of 30. And because I'm adding them in my parentheses, I need a subtract here. It's the sine of the two multiplied together. So I need these four values, and they're on your green sheet, and then I just do the math with them. So what is the cosine of 45 degrees? Square root of 2. You remember where to get them? Cosine is the x, sine is the y. What's the cosine of 30? Times square root of 3 over 2. Yep. Sine of 45 from your sheet? Square root of 2 over 2. And then sine of 30? 1/2.
Punch that all in the handy dandy calculator.
No calculator, because we're being exact. Okay, fractions. So you multiply tops, you multiply bottoms.
Oh, that's true.
Square root of 6 over 4 minus square root of 2 over 4. Well, that's nice. There's a common denominator there already.
Square root of 4 over...
You cannot subtract underneath. Square root of 6 minus square root of 2 all over 4. Done.
Wait, why can't we just subtract square root of 6 and square root of 2?
They're not like terms. They're not.
What do you mean not like? They look pretty like.
They're not. If I had 2 square root of 6 minus 4 square root of 6, I could subtract the 2 minus the 4 because they're like terms. Square roots are their own, like an x. This is like an x and that's a y because they're not the same square roots. So it's not legal to subtract underneath square roots together. Not a legal move from Algebra 1.
You don't need to degrade me like that. So.
Okay. Let's see. Let's do one more of those, I think. The cosine, well, this is still going to count as 1, of negative 105 degrees. Okay. You don't have a negative 105 on there. So you either have to add some angles together or subtract in some way so that you end up with negative 105. Any numbers you want to work with on there, you figure it out. You got to be able to add or subtract to get negative 105. You want to add two negatives together? You can. Or you can do a small number minus a bigger number so that it comes up negative. Either way is going to work. So there's two roads to go down. They're both going to take you to the right answer. What do you want to do? Two negatives added together or a small number minus a big number?
Let's do small minus big.
All right, so find any two numbers on there where the difference is 105. And there's a bunch of them.
See, I got one.
What do you got?
I got 150 minus 45.
So if we went 45 minus the 150, 45 minus the 150, so we got to put it in that order. 45 minus the 150. because that equals negative 105. Is everybody okay with that one? So now you've got an A and a B, and we're subtracting the two angles. So now I just expand, and the identity says take the cosine of the two angles, so that's the cosine of 45 times the cosine of 150.
Not negative 150?
No. And because it's a subtract, we're going to add the two signs. Sine of 45 times the sine of 50.
Of 150.
Oh, 150. Sorry. And now you just look up those four values and you do the simple math. The cosine of 45 is square root of 2 over 2. What's the cosine of 150?
Negative square.
Then we got a plus.
The cosine of 150?
Mm-hmm.
You sure?
I don't know. I don't know.
Yeah, it is.
Okay.
It's negative? Oh, it is. Never mind.
Square root of 2 over 2. And then the sine of 150 is positive. What? Square root of, is, I don't think
Oh,
so.
wait.
Yeah.
Oh, 1/2.
1/2.
Oh my god.
So we're going to have negative square root of 6 over 4. Oops. Negative square root of 6 over 4 plus square root of 2 over 4.
So when it's multiplying, you can add the bottoms?
You multiply the bottoms. Not adding them, multiplying them.
Oh, okay, good. And you can do that.
Okay. And so our final answer, we've got a common denominator of 4. Negative square root of 6 plus square root of 2. The book will probably flip that around and say square root of 2 minus square root of 6.
Which I did.
Which you did?
Yes.
Just because it looks better? I don't know.
Yes.
I mean, not that I would mark it wrong, because it's not. But I'm going to say the book will probably say square root of 2 minus the square root of 6 all over 4. Is it necessary to do that? No. All right.
I'm glad you caught us on your
What? I guess we got a part C to this one.
Can you go back real quick?
Wait, did you say part C?
Yeah.
Like,
Like a 1, an A, a B, and then we're going to do one more.
Still on example
Yeah, we're still on example 1.
When you multiply,
Why are you ruining my life?
you just multiply both, right?
Yeah. Okay, easy one. Still looking for an exact value. Cosine of 29 degrees times cosine of 16 degrees minus sine of 29 degrees times sine of 16 degrees. What do you think of that?
I think this is first.
All right, I don't see a 29 or a 16 on your green sheets.
Oh, can we put them together?
Oh, can we put this together? How would you like to put them together?
Like
Cosine
Of?
29 minus.
Is it minus? Plus 16. Oh, maybe that will help us out. See, this was the identity expanded, and they're saying, oh, well, this is the cosine of the two numbers added together. What's 29 plus 16?
45.
45. Oh, can you find the exact value now?
Yes.
Wait.
Cosine is always opposite.
The middle sign is the opposite of what we're doing.
That's all we had to do.
That's all we had to do, find the exact value. So we took an expanded one and condensed it back. Nice job. I think Austin saw that first.
Yeah, thank you.
Mm-hmm. Nice job. So let's see. Oh no, that was 1, 2, 3. Oh, life might be good for you. I have 2 left. So
Oh.
I wasn't not too far off.
Are these really long?
Oh, that's outside. Oh. Good morning. Yeah. I have lunch in a half hour. Well, 10 after. Yep. Come down to my room. All right. Got the fax number? Okay. Yep, 10 after. Yep. Bye. All right, reduce.
Sorry, Kelly. My look on you, just looking at me. I feel like an athlete. I feel like an athlete.
I don't get the use of it though.
Is this gonna take up as much room as?
No.
Oh, okay.
Very short one.
Your hands on it?
Okay, reduce to an expression with one variable.
Supposed to make you look cool, man. You look like a freaking athlete.
Okay, the cosine of 0 degrees plus theta. So right now I've got an expression that has a 0 and a theta in it. I want to end up with just one variable. So let's expand it with the identity and see where it takes us. So how does this expand?
And then,
Cosine of 0 degrees times the cosine of theta. Then what? Minus the sine of 0 degrees times the sine of theta. Okay, you can look up the cosine of 0 degrees on your sheet. What is the cosine of 0 degrees?
that is one.
I'm going
1
to
times cosine of theta. What is the sine of 0 degrees? 0. Finish it up. What are you going to have?
Cosine of theta.
Good morning. Yeah, why don't you? Bye. Just be cosine of theta. Okay, last one's a long one.
Oh, great. Yay.
Semi-long.
That's it?
That's it.
It's like cosine of theta.
How did we get it?
Oh, never mind, never mind.
Okay, never mind, because 0 times anything.
Yeah, we're good.
Okay, she's good.
Wait, where did this?
I can go back by the 4th grader to help you with that one.
I didn't see it at first.
Where did the
I wanted
sign
to subtract
appear?
first,
Oh.
and then...
What? Because 0, what's 0 times anything?
Oh,
Like I said, I can get you a 4th grade partner too to help you with those ones.
yeah.
Okay.
Let's do it. I'm ready.
Yeah.
I'm ready.
Okay, here we go.
Last example.
This is it. Find the cosine of s plus t and the cosine of s minus t if the sine of s is 2/3 and s is in quadrant 2. I also know that the sine of t equals -1/3 and t is in quadrant 4.
Okay, I'm finished. What's with the S's?
What letter would you like to use?
The Easter egg.
Switch to anything you want, I don't care. The book uses S's and T's and I just like to follow what the book does. You want A's and B's, put A's and B's in. The letter doesn't change the problem.
So when you start with the Jesus fish, you gotta finish with the Jesus.
Okay, are you ready? First thing I want to find is the cosine of s plus t. Well, according to my identity, I need to know 4 ratios to get this. What are my 4 ratios? I need the cosine of s and the cosine of t. Then I'll subtract the sine of s times the sine of t. Okay. Do I know all 4 of those values?
Yeah.
What's the cosine of s equal to? That's the sine of s.
Oh.
So do I know all 4 of them?
No.
The answer is no. Can I find the cosine values? Yes. because I know what quadrant the angle is in, and I know two sides of the right triangle. So I need to sketch angle S in quadrant 2.
I'm just gonna let you sketch that.
Bottom of my paper. Why was that funny?
This is angle S. It's telling me it's in quadrant 2. What do I know about this right triangle?
The opposite is 2.
Yep. The sine is 2/3, so the opposite is 2. The hypotenuse is 3. Could you find the adjacent side now and figure out the cosine?
I mean, sure.
How much Pythagorean theorem do I need to show?
Sure, go for it.
2 squared plus x squared equals 3 squared. Just doing Pythagorean theorem. 4 plus x squared equals 9. X squared equals 5. X equals square root of 5. So, because I'm in quadrant 2, though, what do I need to throw on there? Negative square root of 5. Hey, all that work just to get the cosine of S.
Oh.
What is the cosine of S? Negative square root of 5 over 3.
Why is it over 3?
Why is the cosine of X?
Cosine is adjacent over hypotenuse. Okay? I need the cosine of T. Oh, I don't even have angle T sketched yet. Ugh. So T is in quadrant 4.
I was thinking I was going to be able to cram this at the end.
I told you this was a long one.
Obviously, I was listening. Clearly, I wasn't listening before.
Clearly. T is in quadrant 4. And what two sides of that triangle do I know? The sine tells me opposite and hypotenuse. Opposite, hypotenuse. Got to do some Pythag. X squared plus negative 1 squared equals 3 squared.
I figured we were I never thought we were
Remember to simplify square root of 8, because it's got a 4 in it. 2 square root of 2. And is that going to be positive or negative? Take a look at the direction that x is in. Positive, 2 square root of 2.
cosine. Wait, hold on.
Okay.
Adjacent over hypotenuse. So it would be 2 squared is 2 over 3.
Very good. So now my next one is 2 square root of 2 over 3. Do I know the sine of angle S? We could look at the triangle, but they actually gave it to me on the start. So sine is 2/3. And the sine of t, negative 1/3.
Are they all going to have like an A in front?
I think so. I don't know for sure. Okay. What do you think happens here when you multiply?
Something ugly happens.
Nope, it's not too bad.
Ugly. The number under the square root.
The underneath stuff does multiply. So you will get negative 2 square root of 10 over 9 minus negative 2 over 9. So my final answer as a single fraction Are you okay with that?
No.
Why not?
What is, we still have to find another one, don't we?
Here's the common denominator of 9. So I do negative 2 squared root of 10 minus a negative 2 Okay. Okay.
Instead of redoing it, can we just switch to?
Absolutely. We're going to be very clever here and save ourselves a ton of work.
Oh.
Oh, we're not done.
That's not it. I circled it.
Well, I wanted two things, cosine of s plus t and cosine of s minus t. But be clever. What's the difference between the two identities?
Nothing.
Yeah, something. What was the difference? You would carry through an add in the middle instead of a subtract. So it would be an add here, and an add here, and an add here. So what would my final answer be?
The plus 2.
Negative 2 square root of 10 minus 2 all over 9.
Oh, clever.
Clever.
Will that work for everything?
Yes, it should.
Unless you get it wrong.
Unless you get the first one wrong. All right.
Double screwed.
You get to try. Do I ever do that?
Yeah.
No. Five, 3.
I'm just kidding.
5, 3. 5, 3. There we are.
You know, I can tell that you use the same assignments for like the past couple of years because people circle it in my
Mm-hmm.
book, and it's the same number that I have to do.
5, 3.
Coincidence? I
Trig.
Not.
Common occurrence.
Or?
I do first.
11.
4 and 11. Nice. I like it.
40.
That's a real jump.
44. Yep.
Got lengthy for it. All right, cut her off now.
You can maybe one more.
50. 52.
Most of these are 6 in a row that go on.
There you go.
I like it.
Do you already realize the stress is starting in my life?
Yep.
Oh dear.